Okay, guys, I'm going to be reviewing TEK 5.3i, which is modeling the multiplication of a whole number and a fraction. So there were several different models that we learned how to read, and I thought maybe you may have forgotten those, and so I decided I would go over that real quick with you. So first of all, we'll look at the equal groups model, which is probably the easiest model to read. So pretend we have this problem like, say, Johnny ordered 4 hamburgers from Juicy's for his family, and each of those hamburgers weighed 1/3 of a pound. How much did all of the hamburgers weigh altogether? So this type of problem is just like repeated addition, okay? So we ordered 4 hamburgers. So we drew a lot of these at school. Doesn't really matter if you draw circles or squares here. I guess I'll just draw circles. So we ordered 4 hamburgers. So we're obviously that would be our whole number. So I'm just gonna draw like 4 circles to represent my 4 hamburgers. And each one, each patty on each of the hamburgers weighed 1/3 of a pound. So I need to split all 4 of my hamburgers into thirds. So to split those into thirds, which mine's a little bit sloppy, it's okay. So now I've split them all into thirds, and each one was only 1/3 of a pound each. So how many parts out of each hamburger do I need to shade? Only 1. And so there we have it right there. And so you see this is just like repeated addition. I want to know how many total pounds. And so it would just be the same thing as doing 1/3 plus 1/3 plus 1/3 plus 1/3, which is obviously going to be 4/3, which you could also get that from looking at the model. You could just count how many thirds you have total. 1, 2, 3, 4. 4/3. But remember, we can't leave it as 4/3 because that's an improper fraction. It's turned into a mixed number, which that mixed number would be 1 and 1/3. And so the amount of hamburger meat that was in all 4 hamburgers would be 1 and 1/3 pounds. And so that is how you would read that type of model. All right, so we're going to stick with the same problem, and I'll just review what an area model would look like. So again, we're going to stick with the same problem. We've got 4 hamburgers, and they each weigh 1/3 of a pound. So this is where you would have like your rectangle, and we want to split it into 4 equal parts because we have 4 hamburgers. And so we would just split that like vertically into fourths. So there's my 4 hamburgers, and so I now want to split that into thirds. So to split it in thirds, since these are vertically, I have to do it horizontally. So I'd split it into thirds horizontally. So now I've split in thirds horizontally, and each one was 1/3. So these are your 4 hamburgers. So like 1, 2, 3, 4, and each one is 1/3. So I would just shade in. Okay, there's 1/3 here, 1/3 here, 1/3 here, and 1/3 here. And that would obviously still give you the same answer. How many thirds do you have? 1, 2, 3, 4. You have 4 thirds, which is again the same thing as 1 and 1/3. So that's 2 different ways, 2 different types of models for the same exact problem. Okay, so this same problem could be represented on the number line. So remember, we've got our 4 hamburgers. They each are made up of 1/3 pound of hamburger meat. We want to know how many pounds in all. So we have our number line, and as you can see, our number line is split into thirds. So here's 0, so this would be 1/3, this would be 2/3, this is 1, which is also equivalent to 3/3, so then this would be 1 and 1/3, 1 and 2/3, and then this would be 1 and 3/3, which is also equivalent to 2. So how many jumps, how many hops should we have on our number line? 4, because that is our whole number, and each time we make a jump on our number line, how far does it need to go? It needs to go 1/3. So we just start at 0, we make 4 hops, so 1, 2, 3, 4, and where do we end up at? 1 and 1/3, and should your jumps all be equal? Yes, because each hamburger is the same weight. Okay, and lastly, we'll look at the standard algorithm. So we have 4 times 1/3. Now remember, a lot of you were kind of getting confused at school once we taught division of fractions. You're trying to keep change flip. You do not keep change flip when you're multiplying a fraction and a whole number. And in 5th grade, all your problems will be a fraction and a whole number. It's not going to be like a fraction and a fraction. So first thing we need to do is we need to turn 4, write it like like a fraction. So you just take your whole number and you put it over 1 because this does not change the value of the 4. 4 and 4 over 1 are both equivalent to 4. You can't make the numerator 1 because 1/4 is different than 4 over 1. So the denominator becomes 1. And then all you have to do is multiply straight across. So unlike addition and subtraction, you do not have to find the least common denominator, and you multiply both your numerators and your denominators. So 4 times 1 is 4, and 1 times 3 is 3. So just like on the other models, we get 4/3. And if we have 4/3, that's improper. And so the mixed number is going to still be 1 and 1/3. So remember, there's like tons of different ways that a multiplication could be modeled. So those are all of the ways that you're going to see it. So hopefully that helped to refresh your memory. Okay, so at school, we just reviewed the repeated addition models, and y'all seem to do like really well with those. But remember, there's another type of multiplication models also when you look at it a different way. So if you will remember, the word of means to multiply that little word, and that will come in super handy if you can remember that. So sometimes you might have a problem like this. So this problem says, Hoyt has 12 toys and 1/3 of his toys are Frisbees. How many of Hoyt's toys are Frisbees? So in this type of problem, it's not repeated addition. We're not doing 1/3 12 times. We already have the total. The total is 12, and I want to figure out what 1/3 of 12 is. And so there are different ways to look at this as well. Now we can remember that of means multiply, so we can always do the standard algorithm here, 1/3 times 12. But when you're looking at a model, it's not going to be a repeated addition model. So let me review what some of those types of models look like. Okay, so we're trying to figure out how many of Hoyt's toys are Frisbees, and we want to figure out what 1/3 of 12 is. So this equal groups model is going to look like, like we have to have 12. Okay, so I'm not actually going to draw 12 Frisbees. I'm just going to draw, maybe I should have already drawn this. I'm just going to draw like 12 lines. So that represents Hoyt's entire toy collection. He has 12 toys. I want to figure out what 1/3 of the total number, that's why I drew 12. That's where the 12 comes from. I want 1/3 of 12. So what that means is my denominator is 12. So I have to split my model into thirds. Well, so to do that, I need to know how many to put in each group. How you do that is, what is 12 divided by 3 is 4. That'll give me equal groups. So I'm going to split these into 3 groups because 3 is my denominator, and there's going to be 4 in each group. So that type of model would end up looking like this. And so I've split it into thirds, or 3 groups. So these 4 toys represent 1/3, these 4 toys represent 1/3, and these 4 toys represent 1/3. So how many toys make up a third of his collection? 1, 2, 3, 4. And so 2/3 of his collection would be 8 toys, and 3/3 of his collection, or his entire collection of toys, would be the 12. Well, what are we looking for here? We're looking for 1/3 of 12. So it's not just 1, we're looking for an entire third of his 12 toys. So how many are in 1/3? 4. So the answer would be 4. And that is how you would look at an equal groups model. Okay, so we can also look at this type of model using an array. So in our array, because we're looking for 1/3 of 12, we'd have to have 12 circles. I think we did these at school around Christmas, so we drew Christmas trees and stuff like that. Doesn't really matter what it is. So here's our array that has 12, and we want 1/3 of 12. So we have to split our model up into thirds because 3 is our denominator. Now, it does matter which way you split up your model, because if I split my model horizontally, I'm going to have thirds. But if I split it vertically, I'm going to have fourths, and I want thirds. So I have to split this particular model horizontally to create thirds. So remember, when we split our model like this, and then each row would represent 1/3 out of our total of 12, and we want 1/3 of 12, and so 1/3 would be one entire row, which again would give us the same answer, 1, 2, 3, 4. So 4 of Hoyt's toys are Frisbees. Okay, and lastly, the area model would look like this. Like you would have 12 and you want 1/3 of 12. So you'd have to decide which way to split up your model to get thirds. So just like we were just talking about, so to get thirds, it would be split up this way. And so again, each row would represent 1/3. And so one entire third would be 1, 2, 3, 4. So we would come up with the same answer, which is 4. And again, you can always just do a standard algorithm. It would ask you for 1/3 of 12. Of means to multiply, like we just previously talked about, to turn that 12 into a fraction and not change the value of it. We would just put 12 over 1, and then you don't have to have least common denominator or anything. You just multiply straight across. So 1 times 12 is 12, and 3 times 1 is 3, and that is, if you have 12/3, that is an improper fraction, but that's going to equal a whole number. That's 12 divided by 3 is 4. So out of Hoyt's entire toy collection of 12 toys, 1/3 of them are Frisbees, so that means that 4 of them are Frisbees.